Hello, my name is Julian Carraga, and this is my music genre classification. This is what I did for my supervised learning project. An introduction is the aim of this project is to essentially create a machine learning model that can classify a song into one of 10 genres. And the 10 genres or classes that I ended up using were blues, classical, country, disco, hip hop, jazz, metal, pop. I don't know how to pronounce the genre, and then rock. So initially, what I wanted to do in my proposal, I mentioned how music genres themselves are pretty arbitrary, to be honest. And like, let's say an artist makes a song and he thinks and decides that the genre he created was rock. There could be 20 people who listen to that exact same song and be confident that the song is actually jazz. So I thought it'd be cool if I were able to create a model that doesn't just classify the song into a single class or a single genre, but it would be able to uh, have kind of like a ratio. So like 70% rock, but also 30% jazz. But I wasn't really able to do that. I kept running into errors and I decided to cut my losses and just have a simpler program that works. So some of the related work is I actually took an artificial intelligence class, the one that's provided at this college. And in that class, one of the units we did was actually machine learning. I remember when I took that class though, and when we went to the machine learning unit, I struggled a lot, mainly because since the class wanted to look at like AI as a whole. Machine learning was just one unit, so I think we only had like 2 weeks at most to actually go over the unit. Because of that, everything was very fast paced, and the information didn't really stick with me. But I was at least introduced to the information. However, when I was taking this class and I was watching all the lectures and the course materials, I felt like the information stuck with me, and a lot of the things that I learned made sense, which I was really happy with. And one of the assignments I did was actually pretty similar to what I'm doing right now. Uh, the assignment was essentially predicting disadvantaged communities using classification models like SVM and random forest. And the experiment and assignment as a whole just taught me the full pipeline of data pre-processing, cleaning the data, feature selecting, and just training the model and everything. So I even went back and looked back at my old assignment and referenced it a lot. Another thing that I ended up using was at the end, when I finished the program and everything ran successfully and I got an accuracy that I was happy with, it gave me a confusion matrix. However, it was just on my terminal and it looked really ugly. And I was trying to look up how I can just copy and paste the data onto like a website and just have the website automatically make the data look pretty for me. However, I ran into this article and it showed me how to use my already written program. I just had to write some code at the very end, and it can take the data or the output and turn it into a nice visualization, a nice little infographic that I will show in a bit. But I would like to talk about the dataset that I actually used, which is the GTZen dataset, which I found off of Kaggle, and it includes 1,000 audio tracks, each with 10 genres, and each genre having 100 songs, which is where the 1,000 audio tracks come from. But it didn't just include the audio tracks. Sure, you can go into each audio track, each genre, and then listen to the audio, but it also provides an image of the spectrogram. So if you wanted to train the model based off of the images, you could do that as well. I didn't do that. Thankfully, the dataset it came with like a CVS file that had a bunch of data already included that you can feed the model. And let's talk about what was actually inside of that file. So I remember when I was going into this project, I was wondering how exactly a machine would be able to identify a genre in the first place. Because again, I mentioned it before, genres are pretty arbitrary in my opinion, and I was very curious to know how an algorithm, I guess, would be able to plot the songs on a higher dimensional plane. And it did it by looking at all of these different variables, I guess, or dimensions, even. Uh, Another thing that I was curious about is I've taken a music theory class before, just to fulfill a general ed, but also because I just really like music and I'm interested in music. And I was wondering if that would help me at all. But when I was reading the Kaggle website and I was actually looking through all like the files and everything, I was kind of worried that it would be more audio engineering, which is something that I'm very unfamiliar with. But uh, after looking at all the data, I was kind of able to get a better understanding of what like each point means. Yeah, so for example, like the tempo is essentially the BPM, which is something that I was like, familiar with. However, the tempo itself isn't really a good indication of what song the genre could be, because for example, if we look at a pop song, the song, like a lot of pop songs could be fast, slow, it could be kind of just normal speed. However, this variable or dimension, I guess, is a lot more useful for a genre like blues, because blues songs are normally a lot more slow paced and kind of smooth or whatever. But that's why there's so many different variables or dimensions. Dimensions, as in like when you plot this point in a high dimensional plane, it's kind of the distinctness. I guess I don't really know how to explain it exactly, but that's why there's so many different ways to identify each class or each genre in this case. I chose six, but there's a lot more than six. I think there's like nine in total. Another one that I would like to just go over to give a little bit more insight about the data itself is the chroma STFT, which is essentially the strength of each pitch class. Each pitch class is, there's 12 of them, like C, C sharp, B, B sharp, etc., whatever. And it also could tell us information about the harmony and the chords. So if there's a lot more chord and if there's like really complex chords and harmony, it could point the machine to maybe classical music, because classical music has a lot more complex music, I guess, compared to something like pop, which could be a lot more simple and have very similar harmonies and chords, because pop music is usually pretty popular, which shares a lot of chord progressions and stuff. And then another thing is the zero crossing rate, which is how often the audio waveform crosses zero. And this basically just tells us like how bright the song is. If it crosses zero often, it is a brighter song, and brighter songs are usually like metal. So those are just a bunch of different ways the model is able to identify a genre, I guess. So after understanding the data and looking at it, exploring it, I had to clean the data. And in order to do that, the first thing I did is I just dropped the labels, which was just remove the last column or whatever, or the column that had the labels, and then also removed any duplicates in case there was any duplicates. And then I split the data into features, which is the numerical data, and then the labels, which is the genres, and I used the standard scaler here to normalize all the features, which helped the SVM perform better since it was a lot more sensitive to the scale differences. And then after that, I used the label encoder, which converted the genre names into numerical values. So at the end, I think it was like the last column of the like the data, the CZS, the CVS, CSV, I forgot which one it is called. But the the CSV file, the last column just had like jazz, rock, pop, etc. They just converted it into a numerical value. And then afterwards, I just saved the clean music data into a new CSV file, which I would later open in the next part. But I would like to talk about the classification algorithms that I ended up using. So the first thing I did is I just established a baseline using a simple linear SVM and logistic regression. And it just gave me an initial idea of what kind of accuracy I could expect when I didn't use anything complex. And then after that, I decided to use the RBF SVM model, which is the radial basis function kernel. And this is mainly because of how complex each classes or each genre is. And again, these genres could be a little arbitrary, I feel. So each genre may not be as distinct. And because of this, we would need a more, like, I guess, complex way of being able to classify each genre. So something like a linear line would definitely not work. And I ended up using one versus rest for my classification because it's not binary. I had more than two genres or classes. I had 10 in total. And because of that, I thought one versus rest should be the most efficient. Because if I did one versus one, it would be very, very lengthy and probably take a lot of time. It would more likely be a lot more accurate, but I don't think the computational cost was worth it. So I decided on using one versus rest, and I think it ended up doing pretty well. And then in the next slide, we can actually look at the code itself. So essentially, this was the baseline model, which used the pipeline, and it combined the scalar and the SVM classifier, as you can see here. And I used the RBF kernel here, And then the default parameters, so like I used 1 for the C value, and then I scaled the gamma, and I made sure everything was balanced, mainly because when I was cleaning the data, I lost some songs. So for example, I had it plot each class 0 through 9, which was the 9 or 10 genres, because 0 through 9. And like genre 6 or class 6 didn't have the full 100 songs, it only had like 96. Probably because I guess the data wasn't very useful. It ended up getting cleaned out, so this just makes it so it's balanced. And then after that, but after running it, it gives me just like a rough baseline of what my accuracy could look like and how I could improve it later on. This is just like a little starting point. And then after I did that, I started doing my hyperparameter tuning, which is my grid search. So we have the C value and then the gamma value. The C value is pretty much how far apart each genre or class is. If I remember correctly, the C value, the lower it is, the more loose the like space between each genre is. And the looser it is, the more likely it is to underfit. But if the value is really high, then it is more likely to overfit and be a lot more strict. And then the gamma value is kind of how much influence each individual point or song in this case has on the like borders, I guess. So the lower this value is, again, the more prone it is to be underfitted. And the higher this value is, the more strict it'll be, which is prone to overfitting, and it'll make outliers influence the borders, I guess, a lot more. So you need to have a good balance between the C values and the gamma values in order to not underfit or overfit. And what this essentially does is it creates 7 different C values and 7 different gamma values. This first number is the lowest value we can use, which is 10 to the negative second. And the second number is the highest value you can use, which is 10 to the power of 2, which is 100. So what this does is it chooses 7 equally spaced points between 10 to the negative 2 and 10 or 100. And it does the same thing. It's the same command for gamma, but instead we have 10 to the negative 3 and then 10. And again, it creates 7 points that are equally spaced between this range. And then this is the grid search, which essentially takes the C value and compares it with every single gamma value. So because we have 7 C values and 7 gamma values, we have 49 different combinations. And what this does, it runs through all 49 combinations and returns the best C value and the best gamma combination to give us the best kind of border for every single genre. And then these are the results. So when I actually run the program, this is the output I got. It gives us a little table, 0 through 9, which is each class, which is each genre, and it tells us the precision, the recall, the F1 score, and the support. Again, like I mentioned earlier, when I was cleaning the data, we lost some of the songs, so that's why genre 6 only has 18 instead of the 20 that everything else has. And I ended up doing an 80-20 split, which is, again, the reason why it's not 200 here, which would be a true 80-20 split, is because some of the data got cleaned out. And then this is a confusion matrix I mentioned earlier in the presentation. It looks kind of ugly, but it gets the job done for sure. But I was able to get nice little visualizers. So for example, the first thing I did was I just took this and I just put it onto Google Sheets and I just made a table out of it. And the results themselves, I'd say, are pretty much what I expected. There are some things that I wasn't expecting. So for one, I'm not surprised that classical had the highest F1 score, because classical music is very distinct. I'm sure if you showed anyone a classical song and you asked them, of these 10 genres, which one is this? A lot of people would be able to get classical. And I'm sure because of that, classical music is very distinct, so when it's plotted on the higher dimensional plane, it's probably very far off from the other genres, and I'm sure it's pretty easy to group that class or genre together. I think blues is pretty distinct as well because a lot of the songs are very slow, has a slow tempo, and there's aren't really that many instruments used. Uh, okay, saying blues songs are simple, I don't think is the correct way, but I can't really think of any way to describe it. So I'll just call them blues are very simple. So I'm sure it makes it very easy and distinct compared to the other genres. However, genres like country and metal, I'm a little bit surprised that they have such a high F1 score, mainly because I thought that rock, metal, country, and even sometimes pop would get grouped together a lot. And that is somewhat true for rock. As you can see, rock ended up having the lowest F1 score overall. And again, that's not too surprising. However, the precision was really high. So this implies that the model was able to correctly identify if the song was rock. However, anytime if there was like an actual rock song, it would end up misgenrifying, I guess, the rock song as something else. And if we look at the confusion matrix, we can actually see what the model thought rock was. But another standout is the fact that metal had 100% recall, which means that out of all of the 18 metal songs there were, the model was able to identify all 18 as metal. So I thought that was pretty interesting. But again, if we look at the confusion matrix, we can see that rock was only correctly identified 13 out of 20 times. And of the 7 times that rock was incorrectly identified, it got mixed up with this genre, pop, metal, and jazz, which is pretty interesting because I think jazz and rock are pretty far apart, but I guess somewhere in that higher dimensional plane, there was a point that was probably on, it might even be a support vector that was on that line, or maybe it wouldn't be a support vector, I guess. It would have to be somewhere between jazz and rock, I guess. Rock ended up being mixed up as jazz, which is pretty interesting. Another standout is, I guess, genre 3, which is disco, was mixed up as hip hop 3 times, which is pretty high. And then jazz again, which is very interesting. So maybe jazz had a very, because if you look at this column, if you look at column 5, which is jazz, it ended up being mixed up a lot, which is kind of cool. And then we could also look at pop. Of the 2 times it was incorrectly identified, both times were identified with this. And that doesn't stand out too much because I think these two genres are pretty similar to each other. But overall, I'm pretty happy with these results. I think that the overall accuracy of 89% is a lot higher than I anticipated, especially, again, considering how arbitrary I feel genres are. But yeah, I ended up doing this group project by myself. And because of that, I feel like I was able to learn a lot. Also, I'm really bad at managing my time, and I don't want to put that on my group members. I don't want to stress them out and have them do all the work. So I also felt like I think it's good to have this on my resume. And if I have this as myself, and I feel like I'm able to understand every single component a lot more. And speaking of learning, 4 things I learned in this project is 1. I just like this GIF, but one thing I learned is like how important it is to actually clean the data and everything. Because if you don't clean the data, you can get very, very mixed results. Like, I'm sure if it included some of those songs that ended up getting dropped from some of the genres, I could have very different results. And tuning the model is very important. So being able to adjust those C values and the gamma values, like the parameters, which influences how the RBF, yes, kernel, or whatever, is able to classify genres and group the songs under one genre. And I feel like I understand that process really well, and the whole classification process to begin with. Obviously I didn't really do much regression. There wasn't any really predicting, I guess. So I didn't learn too much about that, but I feel really good about classification. And then I also feel like I learned the importance of like visualization and actually taking my data and making results out of them. Like when I did this was actually really fun to do, and especially matching the colors up with my presentation and being able to look at the data and understand the data as well, like how what each rock song was mixed up as, and just how this graph could provide so much information, which just makes me understand why visualization is super important. But yeah, I think that's pretty much for my projects. Uh yes, yeah, thank you.